Where's my vertex?
-2,
-2, 1. Which way do I open? Down. Everybody get down. Okay, here's my axis of symmetry. What's its equation?
X equals -2.
X equals -2. Here's my focus. How far down do I need to go? 1. Because 4p is 4, so p is 1. If I come down 1, I'm at -2, 0. So my focus is at -2, 0. If I came down 1 for my focus, I'm going to go up 1 for my directrix, so that will be the line where y equals 2. How long is my latus rectum? 4. The whole thing is 4. So I'm going to go forward 2 and backward 2. So from my focus. So if I go forward 2, I would be at the origin. If I came backwards, I'd be at -4. Anybody have a question about that?
Vertex is y equals 2.
Because you went up 1 from the vertex. How many perfect papers? Okay, if you didn't get a perfect paper, have you figured out what you did wrong? Okay, today what we're going to do is the opposite. Here's what I mean. Today, I'm going to give you the vertex, and I'm going to give you the focus, and you're going to write the equation. Okay? So like always, not required, but I'm going to draw a picture because I want to see what this looks like. So -2, 5 is my vertex, and -2, 7 is my focus. Now that tells me something about my parabola. What does it tell me about my parabola? It's opening up, which is important because when I write my equation, one variable is squared and one isn't, right? So my equation is going to have a format, number, not squared parentheses, and squared parentheses. Since it opens up, which variable is squared? X. So I'm going to have a y here and an x here. Now, because I was given the vertex, I can fill these parentheses in, can't I? So this will be x plus 2 and y minus 5. The only thing I don't have is this coefficient. Remember how important that number is? That number is 4p. It's always 4p. And what does p stand for? The distance from, and here's my parabola. It's this distance right here. So that distance is 2. So this number has to be 8. Will it be positive 8 or negative 8? Positive. Boy, that was easy, wasn't it?
Yeah.
Yeah. Well, let's see. Now that Annabelle's here, let's step it up a notch. We got the varsity in the room now. Suppose I told you that the vertex, not the vertex, the focus was -3, 11, and the directrix is the line where x equals 7.
So that means it's a y squared root I.
Well, let's visualize this. Negative 311 would be over here. This is the focus, and not the vertex, that's the focus. And the directrix is x equals 7. So that's the focus, and that's the directrix. Now, what does that tell you about how you open?
That means it's a negative. That means it opens to the left.
Does everybody see it opening to the left? Remember, it has to enclose its focus, right? And it opens away from the directrix. Okay, so it opens to the left. All right, so what does that tell me about my equation?
Y squared.
The y is squared. Tells me something else too.
Tells you that it's
The
negative.
coefficient out in front of that is going to be negative, right? Would you agree with that setup?
Yes.
Okay. Now, we need to figure out our vertex, obviously.
Vertex is this half the distance between.
It would be right smack dab in the middle here, wouldn't it? Because remember, when you found your focus and directrix, didn't you go the same distance both directions? Your vertex is equidistant, it's right in the middle. So what would the coordinates of that point be then, if it's right in the middle here?
211.
211. Does the 11 make sense to everybody?
Yep.
How'd we get the 2?
You go 5 because it's 10.
Midpoint? What's right in the middle of negative 3 and 7? Negative 3 plus 7 is 4, divided by 2 is 2. Or you can count. So I can put a 2 here and an 11 here. Now what?
Now we have to.
I need the coefficient. This is 4p. I can tell from my picture that p is what? P is 5. So 4p would be 20, and you already marked it negative because it opens to the left. Everybody okay with that?
Yeah.
All right, let's have you try one with your neighbor. Make sure you got it. Let's say our focus is 3,1, and our directrix is the line y equals 5. See if you can write that equation.
So it opens down to, is it 5 and 3 or?
Okay, how we coming?
Okay.
shout out an answer here. What'd you get as your equation? Negative 8.
Y minus 3.
Y minus 3 equals x minus 3 squared. Anybody want to argue? I did not do the problem, so I have no idea. Anybody want to quibble with that? I think that's good.
I have a question. So the coefficient always goes in front of the one that's on the square.
Think about when you put it in standard form, you complete the square, and you have to get rid of that number. It's always away from the square. Katie?
Does it matter if you put like negative 8 and then parentheses x minus 3 squared equals y?
That's what she just said. If you're going to use negative 8, it has to be attached to the unsquared term. Remember what we did yesterday when we completed the square? You have to get rid of that coefficient. The coefficient has to be away from the squared term. Now, we talked about that you could see this equation in different forms. When we are building the equation, if you're using the 4P idea, then this is what's going to come out. This is the equation you're going to build. But this is the same equation as this. So you could see this equation in different forms. You're not going to build it in that form, but you can see it in that form. Those are the same equation. But if you're using negative 8, it's going to be put to that y. Okay? Thomas, what are you doing? What did you say?
I said I was finishing a paper. I did the math.
Madeline?
Yes.
Do you want to tell Tom what happens when he does something he's not supposed to be doing on his iPad?
She'll email your parents and some counseling.
Oh. Yeah, Madeline.
Okay. All right. We'll do a couple of things. First of all, I want to practice putting another one in standard form. Because on test day, which remember is probably going to be right after Easter, the equation is going to be as nice as it was on your quiz. The equation will probably look something like this. All right, so let's practice this one more time. We're going to put it in the right form, and then we're going to find vertex and focus and all that stuff. So how do we start? Well, we have to do two things. One is we have to multiply by 4. And the other is subtract what's now the 48. You can do those two things in either order. Okay? Now we're ready to do what? First we have to complete the square, don't we? So we're going to take half of 8, which is 4. We're going to square that and get 16, and we're going to add that to both sides. So 4x minus 32 equals y minus 4 squared. Stop me if I make a mistake. We're almost done. Last thing, take the 4 out. Now, Carter Habecker, you're looking quite relaxed back there. You need to be able to do this, Carter. Do you feel confident you can?
Not quite yet.
Huh?
Not quite yet.
Then how come you're not doing it with me? I know, but watching doesn't work. Do you know how many soccer games I've watched? Like 80,000 million. And do you know how bad I am at playing soccer? You can't just watch. You have to do it. Okay? So let's get our pencil out. Let's get our paper out. Let's start putting the pencil on the paper and writing meaningful things. All right, where's my vertex?
8, 4.
8, 4. Which way do I open?
Up.
we go, we're opening to the right. What's my axis of symmetry? Y equals 4. My focus is in there somewhere. What can you tell me about that focus?
That it is 2, 1. It's the P is 1.
Right, and if the P is 1, Mr. Stark, that means that the focus is 1 unit away from the vertex.
It's 9, 4.
Good. And similarly, the directrix is 1 unit
Backwards,
the other way.
so it is X equals 7.
Good.
Woohoo.
How long is my latus rectum top to bottom? 4. That means I will go up and down 2. So this point would be 9, 6, and oops, and 9, 2.
And now it's yeah.
All right? Okay. Now we're going to do something that is even more interesting. We're going to look at this equation. Now, the first thing that you notice about this, I hope, is that it is not a parabola. How do I know it is not a parabola?
2 squared.
Because I have 2 squared terms. Okay, but wait a minute. A couple nights ago, you had some circle homework. By the way, I had a mistake on the answer sheet. That's already been corrected. Thank you to the guys in the back. And one of the equations on there looked something like this. I don't remember it exactly. But that was a circle, right? And what can you tell me about that circle? Its center is the origin, and its radius is 4. That equation, if you wanted to, we never do, but if you wanted to, you could write that equation like this, right? Dividing by 16. And this would still represent a circle centered at the origin with a radius of 4.
Kill it.
Okay. Now take a look at this equation. It appears it's still centered at the origin, but now the numbers in the denominator don't match. If they were both 9s, this would be a circle centered at the origin with a radius of 3. We would count this way 3 and up and down 3. Now, that was originally 9. This one is the one I changed. The fact that that was originally 9 means I'm still going to count back and forth 3. That hasn't changed. That radius in the x direction is 3. But the radius in the y direction is 2. So instead of getting a circle,
I got an oval.
I have what's known to the mathematician
That's an oval.
as an ellipse. I need you to kind of get that what you talked about with circles is the same as with an ellipse, except the radii aren't the same. You go a different distance in the x direction than you do in the y direction. This particular ellipse is stretched horizontally. Agreed? The longer axis is called the major axis. So for us, our major axis is horizontal, and it is 6 units long. Because you went 3, 3. Any guesses what this guy is called? The minor axis. And for us, he is 4 units long, because we counted up and down 2. These points are called the vertices of the ellipse. So our vertices are 3, 0, negative 3, 0, 0, 2, and 0, negative 2. Now, so far, have I said anything that's perplexing you? When you do problems in your book, and if you use the answers in the back, when they list the vertices, they only list the major axis ones. Do not be confused by that. When they list the vertices, they're only going to list these 2. Because the major axis is the important one. And so they count these as the only vertices. I count these 2 because I need them in order to sketch the picture. Okay, so don't be confused by that. Now, what is so important about the major axis? Well, that's where your foci are. The ellipse has 2 focus points, and they are always located on the major axis. Now, is the major axis always horizontal?
No.
No, it just happens to be in this case. In order to figure out where the foci are, well, we know they are something comma 0. You agree with that, right? They're something comma 0. In order to figure out the something, we need to know this distance. In this ellipse, the distance center to focus is √5. Now, this distance right here is √5. Can you tell how I did that? Can you look at the equation and maybe see how possibly I got √5 out of that equation?
2 plus 3.
Oh my gosh, I never thought about that. Yeah, it's actually 9 minus 4.
But 2 plus 3.
That's not going to work every time, no.
But it worked out.
It is. It's the square root of 9 minus 4. The square root of 9 minus 4 is how we do that. And the 9 and the 4 are the denominators, so I just subtract the denominators. Now this is all Pythagorean based. On Monday, we'll spend more time with the ellipse. I'll give you the definition and all that stuff. But practically speaking, to find the distance from the center to the vertex, or excuse me, from the center to the focus, center to focus, we just subtract the denominators and take the square root. So what would these points be? √5 and negative √5. Okay, we're going to do one more, and then I'll be quiet for the day. So here's one more. Okay, so far, I'm expecting you to find the center. Where's your center? Your origin. Your vertices, now that's how far out you go, how far up and down you go.
X, 4,
So
Y.
in the X direction, we're going 4. And in the Y direction, we're going 5.
That means it's a vertical.
Everybody okay with that? So I'll just connect those for my own. long is my major axis?
5.
Oh, whoa, 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 whoa.
10. Oh.
Major axis is 10. And the minor axis is 8. Now, actually, 5 has a name. That distance does have a name. It's like the radius. It's called the semi-major axis. The semi-major axis would be half of the major axis. Now, my focus points are going to be somewhere on here, right?
Yeah.
I need to figure out that distance, center to focus.
25 minus.
In this ellipse, it's the square root of 25 minus 16, which is 3. So where are your focus points? 0, 3, and 0, negative 3. Okay, so now we got a jump start on the ellipse. We'll talk more about it tomorrow. You can have the rest of the period to do a little homework, or if you had a circle question, you can bring that up to me also. Would someone over there turn that off?
You got it.